So I hope you had fun with my little unit circle challenge. You're all getting better at it. That's wonderful to see. Great job. Today, though, we're going to look at something a little bit different. Graphs! Yes! Did you know that you could graph a trig function? Like you can graph like the sine of x. What? That sounds insane. What would that even look like? Here's a hint. It's that. So if I were to graph it, remember, if I made any function we can graph, like a line or a parabola or rational function or whatever, and they have different shapes. Well, we can also graph these trig functions. Y equals sine of x, for example. And if I do, we get this shape on the screen. What's that shape? What's that look like? What would you call that if you were to describe that? A wave, exactly. So sine and cosine make a wave pattern. You may have seen this in science classes, perhaps, and you talk about waves and oscillations and stuff like that. And so sine and cosine make waves. So let's learn about these wave graphs because we haven't actually analyzed these before. And we're going to need to learn some new terminology to describe the waves because waves can actually look a little bit different where they are on the graph and stuff like that. And so these trig functions, by the way, we're just going to look at sine and cosine graphs. Those other trig functions, including those reciprocal trig functions, they do have graphs, but we're not going to look at them this year. Are you okay with that? Just looking at just two? If you really want to learn about them, if you want like to hang out after school, we can look at like some cotangent graphs. I guess that'd be all right. But I don't think I'm going to have a big turnout. So let's just look at these. There are three specific properties or features of these graphs that we're going to look at and to analyze and to determine, and they're written right here. We need to identify the midline of the wave, the amplitude of the wave, and the period of the wave. So we're going to look at what each of these look like on the graph and how to identify them and their values. And then based on those, we can write an equation for it. First thing is the midline. Now, just as the name kind of implies, it's the middle line. It's in the middle of the graph or of the waves. This is a horizontal line that kind of cuts the wave right through the middle of it. So some parts of the wave go above the midline, other parts of the wave go below the midline, above and below, up, down, up, down. The important thing to get that specific number is that this midline is going to be equal distance, because it's got to be in the middle. It's got to be like exactly halfway between the top of the wave and the bottom of the wave. And those actually have their own names. The top of the wave, or the highest point of the wave, is called the crest. So the crest of the wave, that would be up there, up there. They're going to be at the same height. The crest is always going to be at the same height for these wave patterns. The lowest point of your wave is called a trough. That's just the bottom. So like there's the trough, there's the trough. Notice that they're also at the same y value. And so to determine the midline, you can simply just either look at your graph. Oftentimes students can just kind of visualize it and see, oh yeah, right in the middle, it's right about there. But to make sure that you definitely do have the midline, you're really counting the points away from the midline to either the crest or to the trough. It's got to be the same distance. So if I start at the midline and I count it up to the top, that's 1, 2 units to the top, but also it's 1, 2 units down to the bottom, to the trough. So because that midline is 2 units, below the crest and above the trough, we know that that is definitely the midline. It's perfectly in the middle of the highest point and the lowest point of the wave. Also, your midline, if I ask you, hey, what is the midline? We would write it as an equation, y equals 3. Not just a 3, because it's not just a number, it's an entire horizontal line where y is equal to 3. So make sure you've got that included if you're ever asked for, hey, what's the midline? Or where's the midline? Put the y equals in front of it. All right, can you identify the midline of this one on your own? So that's example 1. Take a look at it. I know it's kind of small in your notes, so I've got it a little bit bigger right here for you if you want to see what those values are. And on your notes, I want you to just write out what that midline is. Can you identify it yourself? Remember, it's got to be the same number of units away from the crest and from the trough. Nice. Cool. All right, so if you just try to visualize it, you might just pick some random line and be like, oh, is this in the middle? I don't know. Double check it first by counting. From here, if I go up 1, 2, 3 units, I get to the top, but 1, 2, 3, 4, 5 units gets me to the bottom. So because it's not the same distance to the crest and the trough, that's actually not the midline right there. For this one, it's actually going to be at -2, where y is equal to -2. Because from here, if I count up to the crest, 1, 2, 3, 4 units, and if I count down to the trough, 1, 2, 3, 4 units. So that line is the exact same distance between the crest and the trough. Another way you can do this to easily determine that midline is look at the value of the crest and the value of the trough. And essentially all you're going to do is average those two numbers. That's actually how you find the middle of two things. You add them up and divide by 2. So if I took the number 2 and I added that -6, I get -4. If I divide that by 2, I get a -2, which is in fact the midline. Not just 2, but make sure you put y equals -2 because it is a line. So the midline is located at y equals -2. So usually you can just kind of visualize it, but if not, just add up the top and the bottom and divide by 2, and that will be exactly what your midline is. Just an average of the crest and the trough. Are you okay with midline, everyone? Super duper. All right, next thing we're going to look at is something called the amplitude. Have you ever heard of the amplitude in terms of like music or sound, things like that? Like the amplitude, or an amp is typically what you call the big speaker you plug like a guitar into to make the music really loud, because it's taking that sound wave and making it bigger, making it louder. So the amplitude is basically how big the wave is in terms of like height, like how far above and below the midline that is. So to find the amplitude, you're really just measuring the distance from the midline to either the top, to the crest, or from the midline down to the bottom, to the trough. The important thing that most students will get confused about is it's not the distance from the crest all the way down to the trough. It's half of that. So you want to make sure that you identify the midline first, which is at y equals 0 in this case. Then starting at the midline, just count either up to the top or down to the bottom. It'll be the exact same thing, the same value, the same number. Right, so from the midline up to the crest, 1, 2, 3 units. Or if I count from the midline down to the trough, that's also 1, 2, 3 units. So because of that, we'd say that this wave has an amplitude of 1, because the height is 1 unit away from the midline, essentially. Now, we don't care about positives or negatives. It's always going to be at the absolute value. So we're always going to take the positive version of this amplitude because it's like a distance. Like how far away is that crest from the midline? So we're just going to use A to represent amplitude. Easy enough? All right, can you identify the amplitude of this graph? It's right here for example 2. So you got another slide it in your notes. Just like I did, I would suggest finding the midline first, drawing in the dashed midline, and then use that to try to figure out, hey, what's the amplitude of this graph? Because it's just the distance from the midline to the crest, not from crest to trough. Nice. Excellent. Good. Awesome. I saw a number of students identify the midline first. That's fantastic because that kind of helps you to use that as your baseline to determine the amplitude. And so for this one, the midline would be right here at y equals -5. And then from that midline, we can just count from the midline up to the crest. And hey, that's 3 units. And just to make sure that we've got it correct, check the distance down to the trough. 1, 2, 3. It's the same amount. Therefore, the amplitude is, in fact, 3. A equals 3 for this graph. Are we okay with both of those concepts? Are we good with midline and amplitude at this point? Pretty straightforward, right? All right, now for the third part. This one's a little bit different. So the waves, all waves have a property called the period of it. And basically, that's the part of the wave that kind of repeats over and over and over again. And so when I refer to the period of the wave, it's kind of what we call the wavelength, or the length of a single wave or a single cycle. You may have noticed that these graphs of these waves kind of just repeat themselves over and over and over and over again. And so if I started at any point on this graph, let's say I started down here, and I traced a section of this wave that kind of went through every possible y value and then went back to like the start, this segment right here that I drew would be called one wavelength. Because what I can do now is take that wave, and if I were to make a copy of it, like make a stamp or something, so I made an exact copy of it, if I were to take this and start this one where the previous wavelength ended, look what happens. It matches up perfectly. And I could keep on using that over and over and over to basically replicate the entire wave. It's taking that single wavelength and just duplicating it over and over and over again. Now I can do this with any part of my wave. For the most part, like for this year in Algebra 2, you're probably going to want to start right on the y-axis when x is 0. And because you want to figure out what's the length of that wave, of one single cycle or one single stamp that you could like duplicate. So if I start right here and I go down and back up, see how I kind of started at the top of my wave? I started at a crest and I ended at a crest. That's another way to verify, yes, this is one full cycle of my wave. That's one complete wavelength. The period is simply the length of that. You're going to look at the x-axis. Well, if I look at the x value at the end of that, it's 2 pi. And I started at 0. So then I know my wavelength is exactly 2 pi. Remember, 2 pi, that's a unit of distance. That's like the distance all the way around one circle. And so this wave has a period of 2 pi. Now, even if you started somewhere else on this wave, if I didn't start on the y-axis, like, what if I started right here at pi over 2? If I start here, I'm going down first, then I kind of go up, and I'm back at 0. Is this one wavelength that I've highlighted in blue, everybody? Is that one complete cycle? It's not. Even though I'm back at like my starting value of 0, if I took this and duplicated it, it wouldn't be repeating the pattern. I don't have that like top portion. I'd have to keep on tracing it back to the top and then go down. And right there, that would be my wavelength. Some of your waves might look like this. But the nice thing is the period will still be the same, no matter like which section of the wave you take a look at. Because if I took 5 pi over 2 and I subtract 1 pi over 2, well, what's 5 minus 1? And what's 4 over 2? It's 2. So this would be the same as 2 pi. Or if I subtracted, took my final value and started my initial value, I'd get 4 pi over 2, which is the same as 2 pi. So that's the period of the wave. It's just the one single wavelength, one section of the wave that would repeat itself over and over and over to create the whole pattern. So take a look at example 3, and I want you to tell me what is the period of this wave. So start at some point and try to figure out, well, what's the length of one full wave, one complete cycle before the pattern repeats itself over and over. And that's going to be your period. Awesome. Good job, guys. Yeah. Yep. Yep. Well, no, just the period, it's just that length. So take the final value, subtract the initial value, and that is the period. So where's the pi at 0? Or where's the wave starting at 0? Mm-hmm. So that 0 would be the x value. That'd actually be down there. 0, negative 1. That's technically the starting point. Like here, see that point? Like that would be my starting point. So this one, if I did want to start and measure it from like a crest to a crest, why would that be difficult for this specific graph? I don't know exactly what that value is, do I? I'm like, well, that's somewhere in the middle between 0 and pi over 3, but we can't be certain. So we don't want to use that for our starting and ending point for one wavelength. So I'm not going to figure out, hey, what is it going, starting from crest, ending at the crest. Instead, we could start right here on the y-axis. And from here, we start by first going up to the top and then down. Is that one wavelength right there? No, because that pattern's not going to be repeating it. That's only half of it. I have to continue going down to the bottom. And then we would end it right there. That's one cycle. That's one wavelength. Up, down, and then back up. Because this could repeat over and over and over again. Take a look. If I do trace this up, down, up, and end right there. So watch what happens. If I made a copy of this wave, a duplicate, see how I can take this and match it up right here, and it kind of fits that same pattern? I could duplicate that again, and same thing. I can match it up. I can duplicate that, so I can take this single image of a wave. This is one wavelength, and it kind of just would continue that pattern over and over and over again. And I can see that entire wave pattern continuing from that one segment, that one chunk of a wave. So now we just need to figure out what's the length of that single wave. And here's where we're looking at essentially the x values at each of these points. Here I'm at 0. My wave ends right there at 2 pi over 3. So from 0 to 2 pi over 3 is 2 pi over 3. You don't really need to subtract anything there. So then the period equals 2 pi over 3. Anyone else get 2 pi over 3? All right, all right. So that's the period of the graph, the period of the wave. Example 4, can you put all three of these together? There's a single graph. I want you to identify the midline, the amplitude, and the period of that wave. Can you find all three parts on your own right now? Rockstar. Why are you so good at this?
I don't know, bro.
What?
Very, very nice. Well, see how I did this? I made sure I knew what I was doing first. I'm not saying you don't. I'm just saying I made sure.
He's being responsible. Awesome, awesome. Doing awesome. We're good. Figuring it out. Yeah. All right, so midline, amplitude, period of the graph. So your midline would cut right through the middle, horizontally. So that kind of splits the wave right across the center from left to right. So that midline would be at y equals positive 3. Amplitude is the distance from the midline to the crest or to the trough. It's going to be the same thing. Starting at the midline, measuring up, how far to that crest? Just 1 unit. So A would equal 1, amplitude of 1. Finally, the period of the graph, what's this going to be? I generally try to start on the y-axis if I can. If it's a nice, easy part of the graph to duplicate, I always start at 0 on the x, when x is 0, that'd be right here on the y-axis. And mapping that out, we'll trace that wave. It's going down to the trough. It's going to curve up past the midline and end back at the crest. Went from crest to crest. So I just look at the x-axis from those 2 points, and from 0 to 4 pi is, well, it's got a length of 4 pi. So that would be the period of this wave, 4 pi radians. Who had all 3 of those? 3, 1, and 4 pi? Oh, man. How great. This is almost too easy, right? Good. So now that we can identify those, we want to see how they relate more specifically to our graphs and how we can actually write the equation of them. Because each of those parts, each of those 3 things that you identified will contribute to the equation. Now, like I said earlier, we're only going to be looking at 2 different types of graphs. We're going to be looking at a sine wave, and we'll be looking at a cosine wave. Now, in that graph right there, I do have both of those waves graphed already for you. One of them is red and solid. That's the sine wave. The cosine is blue and a dashed line. Other than the color and the type of line, what's different between those 2 graphs? Say a little louder. Yeah, their starting point. Do you see how the sine wave starts down here at 0, but the cosine wave starts at 1? Why is that? Any ideas? Exactly. If we treat our x-axis as basically these angles, right? Pi over 2, 3 pi over 4, whatever, pi. Think of those as an angle. If we start at 0, well, at our unit circle, what's the value of sine and cosine at 0 degrees or 0 radians? Cosine is the x-coordinate, isn't it? The first number. Well, what's the x-coordinate at 0? Cosine is 1 at 0. That's why here the cosine graph starts at positive 1. Because if you actually typed into your calculator the cosine of 0, you get 1. The sine, if we look at that, the sine of 0 is 0. If you type sine of 0 into your calculator, you get 0 because the y-coordinate at 0 is 0. And so our graph of sine starts at 0. So on the unit circle, cosine starts at 1, sine starts at 0. But as we rotate around this unit circle, I'm adding in different degrees. That's equivalent to moving more and more to the right on the x-axis. I'm plugging in larger angles. I'm putting in bigger numbers for x. That means we're kind of rotating around the unit circle. Eventually, I get up here to pi over 2. Now at pi over 2, things kind of switched because my coordinates are now 0 and 1. So the cosine at pi over 2 is 0. And take a look at this blue line. See how it's down at 0 now? The y value is 0. But sine is at a 1 at pi over 2. So that's why sine is up here at positive 1. If we keep on rotating around, bigger and bigger angles, moving more and more to the right until we get to pi radians. And what happened there? Well, now the cosine is negative 1. If I look at this, right, the x-coordinate is negative 1. So my cosine graph, look how it's way down here at the bottom now. It's at a negative 1 on the y-axis. Sine is 0. And you can see that right there, that red curve, it's at 0 when x is pi. And we continue going around over to 3 pi over 2, down at like 270 degrees. Cosine is 0, but sine is negative 1. And we continue that around, coming full circle, all the way back to 2 pi, which is right where we started, where sine was 0 and cosine is 1, just like we see over on the left side on the y-axis. That's where we started. And that's if I went all the way around from 0 to 2 pi, or 0 to 360. But what if I keep on going? What if I try another cycle, another circle? What's going to happen to my y values? Will this coordinate be any different, this 0, 1? Will that ever change? No matter how many times I go around the unit circle, won't that always be 0, 1, 0, 1, 0, 1 up top? That's why this graph kind of takes this repeating pattern. The wave's just going to keep on going up, down, up, down, up, down. Because when I rotate around and around and around this circle, I'm just going to keep on hitting those same 4 numbers. The 0, 1, 1, 0, negative 1, 0, 0, negative 1. So your graphs just kind of keep on bouncing in between those over and over and over again. So if I took the sine of 3,000 degrees, it's going to be a number on here. It's going to be something between a negative 1 and a positive 1. And so that's how we get that actual wave shape. Cool? So how do we use this information to actually graph our trig function? Well, those 3 properties that you determined earlier, the amplitude, the period, and the midline, actually are components that go into our function. This is our ultimate goal. I want to write an equation. If I look at a graph, so if I see a graph of one of these waves, I'm going to be able to write out that whole function. Now, 2 of these are very straightforward. Amplitude, A, that goes in front. Another thing, do you recall any functions throughout this year where you have a number in front that we called A, and that's usually what we call the vertical stretch? Well, this is kind of doing the same thing. Isn't an amplitude like stretching the waves like taller and shorter? Same exact concept. It's still doing that same thing. So A is your amplitude. That's your coefficient, meaning it's going to be right in front of your trig function. Next comes the actual trig function itself. I have sine written here, but we can also have cosine written here. So know that it's not always going to be sine. We have to look at the graph and determine, is this a sine wave or a cosine wave based on its starting point. The other easy part to identify is going to be C, that midline, because you just add that to the end. Another way to think of that in terms of our earlier functions in the year is that's just your vertical shift. Did it go up 3 units? Then you write a +3. If it's down 2 units, you'd write -2. So those 2 pieces are actually the same thing that we've learned before. But this middle part, B, this is going to be a little bit different. In fact, B, I've called the frequency, but that's not what I referred to earlier. That's not what I had you identify on the graph. I had you identify something called the period. Period and frequency are very closely related. While the period is simply the length of a single wavelength, a single cycle, the frequency is the number of times that full wave completes itself within a 2 pi area, within a range of 2 pi or domain. And so if your wave's really tight together, if there's a whole bunch of teeny tiny waves, like going up and down, up and down, up and down, it's going to have a high frequency. Meaning it's going to be a much bigger number because I've got a whole bunch of complete waves in between 0 and 2 pi. But if I stretch it out and make a really long, really low kind of wave, that'd be referred to as a low frequency, and it would have only 1 or maybe half of a wave or a fourth of a wave. So the way that I get this number, this b, that's going to go inside the parentheses in front of my x variable, is I use this equation, this little mini formula. Essentially, we take 2 pi, which is the standard amount for a complete rotation or a complete cycle, and you divide it by the period. So, hey, normally it's 2 pi, but how many cycles do I, if the wavelength is shorter or longer, how much does it fit in there? How many of those waves can I fit into this 2 pi length? Just take 2 pi and divide it by the period p. That's what we actually had calculated earlier from the graphs. Also, there's another version of this formula. If we're using degrees instead of radians, what do you think is going to be in the numerator? What numbers should we put on top if it's in degrees? Two pi is how many degrees, everybody? 360. 360. Thank you so much. That's exactly right. Yep, so just based on your units on your graph, on your x-axis, if it's in radians, use 2 pi divided by the period. If it's in degrees, we use 360 divided by the period to get b, this coefficient that goes with the x. All right, so make sure you add that in. All right, I'd like you to write the equation of a function, and here I'm just giving you all the pieces. All right, so I'm telling you first it's a cosine wave, so use cos in there. Amplitude of 3, midline of -8, period of 10. Go ahead and write that entire function out. So f of x equals. So the first thing that we write is the amplitude, A. This tells me that the amplitude is 3, so I start by just writing a 3. Next comes the trig function itself. Now, inside the parentheses of that trig function, for the angle, I'm going to have an x in there. That's my variable. Got to have that variable in there. But then there's b. Now, b is the frequency. I didn't give you the frequency, though. I gave you the period. So we wouldn't write 10x. I have to calculate the value of b, where b is 2 pi divided by the period. Well, I know what the period is. It's 10, so that's 2 pi divided by 10. And I can just simplify that fraction then. 2 over 10 simplifies to 1 over 5. So this would be pi over 5. That's b. That's what's going to go into my parentheses in my function. Pi over 5 x. So that's the coefficient of x. Pi over 5 x. And then the last thing we have after those parentheses are closed, coming at the end of our function, is the midline, which is -8. So 3 cosine pi over 5x minus 8. If you put the x up in the numerator with the pi, that's totally okay also. No big deal. Anybody else get that? Just out of curiosity? A few of you? Awesome. Now, I'm not always going to give you the values, though. What I want you to be able to do is to write this trig equation by identifying all of these properties on your own from a graph. So if I gave you just some graph of a wave, can you write the equation for it? Can you identify these properties and then put them in the correct spots in that equation? So there's 5 things we need to kind of figure out. First, we need to know what wave is it. Is it a sine wave or a cosine wave? Remember, the difference between those two is just the starting point for the most part. Find the midline, the amplitude, the period. We get that from the graph, but remember, then you use the period to to calculate the frequency. And that's what's actually going to go into your equation. So for example 6, write the equation for the graph. Now, step 1, I need to determine what kind of a function is this, sine or cosine. The best way to do this, everybody, is look at the y-axis or look at the y-intercept right here. If it's sine, then I know that I'm going to kind of start in the middle of my wave. The wave's going to go up, down, up, where the y-axis is kind of crossing over like my slope part of it. Cosine starts at the top. The cosine wave would start up here, go down, and end here. So that's cosine, where sine will start in the middle, go up, down, up. So that's kind of like the different generic shapes of a sine wave and a cosine wave. Because sine starts at 0, now it won't always be 0 on the graph because remember that midline can shift. I could move that graph up several units, so it won't always be on 0. But cosine always starts at a crest. Also, these could be flipped if they're upside down. But we're not going to look at any flips this unit, but just know if it starts in the middle of that increase or decrease, it's sine. If it starts at the crest or the trough, it's going to be a cosine wave. So looking at this, everybody, is this sine or a cosine wave in example 6? Yeah, it's a sine wave. You trace out that pattern, it's going up, down, up. That'd be one complete cycle. That's a sine wave. And if you forget what sine does, think about the unit circle at 0. Sine starts at 0, goes to 1, 0, -1, back to 0. That's literally what it's doing. It's going up 1, down to 0, down to -1, and back. It's just the midline and amplitude kind of change it. So go ahead and identify all those properties for this graph. Once you've identified them, then you can go ahead and write that function. Plug it all in. For A, B, and C. What's pi divided by pi? Well, they're just separate. Like pi is just a number. So if you have a pi on top and a pi on bottom, you just cancel them out. What's 2 pi divided by the period? What's 2 pi divided by 2 pi? Yeah. But you still need your variable. You still need to put x in there. It's 1x. Because otherwise you would just have, because that would just be like, oh, it was there the whole time? Oh, I missed it. Because the sign of 1 would just be a constant. The first two parts that are easy to identify would be the midline C and the amplitude A. where that midline cuts through the middle, and from there, midline to the crest is 2 units. And so I've got A and C. Those numbers will both go directly into my equation. But now I need to identify the period in order to get the frequency. Period, well, I already traced out one wavelength here. Up, down, up. And I just look on the x-axis. The period is 2 pi. So when I calculate B, the frequency, I start with 2 pi, but I divide it by whatever the period is. It just so happens that this does have a period of 2 pi. Just a coincidence. 2 pi divided by 2 pi equals 1. Anything divided by itself equals 1. And then also we already kind of determined that this is going to be a sine wave because it's following the up, down, up pattern starting from the y-axis. Now if we were to put all these pieces together to write out our equation, f of x equals, always start with a, amplitude, that always comes first. Write the trig function next. Inside the parentheses goes b and x. Now b is the frequency, 2 pi over 2 pi is just 1, so I don't need to write the 1, but you do need to write the x. You need to have that variable. Sometimes students will just write like 2 pi over 2 pi or whatever, just that fraction, but you need to have your variable in there to make it an actual function of x. Then the last thing, c is 3, so I'm just going to write that as a plus 3 because it's a positive 3 for that vertical shift up 3 units. Anybody have 2 sine x plus 3? Yes! Super easy, right? Not the worst thing in the world. All right, try one more on your own. Oh, no, it's game time then. Yeah, we're going to have some fun. Yeah, for sure. Why do you look so nervous? Like, games, no, I don't. It does not involve a circle. Does not involve a circle at all. It involves 3 circles. No, just kidding. All right, if you've got this, and some of you are already working ahead, that's fantastic. Love seeing what you came up with. Yeah. Yes, because if you start like on the y-axis, see what you traced? You started at the crest, and you went down, and then you ended at the crest. That's what makes it cosine. Whereas the sine started in the middle of the wave, like of that upstroke, you know, had to go up and down, then up and ended. Like starts on the midline, ends on the midline, it's sine. If it starts at the crest, ends at the crest, it's cosine. Is it 1/3? Are you sure?
I think so.
Yeah?
Pi over 6 pi?
2 pi over 6 pi? Is that 1/3 pi?
No.
It's pi over 3.
It's a pi over 3?
There's no pi.
It's one.
What happens to the pi's?
They cross, so it's just.
So there's no more pi.
So it's 1/3.
Just 1/3 in the parentheses?
Yes. Well, 1/3 x.
You need that x, don't you? Mm-hmm. All right, I'm going to start by drawing my midline and identifying where is that midline. That's C at -2. Typically, that's what I start with. From the midline, how far is it up to a crest? Well, that's just 1 unit. So we got an amplitude of 1. The full title is Wojiwan Kenobi.
Yeah. But it doesn't say I.
Well, there's limited space. And I know it's a beast name because it's me. Anyways, so from here, next thing we're going to find is the period. Again, I would starting at on the y-axis, trace out one complete wavelength. And that's going to tell us two pieces of information. First, it's going to tell us, is this a sine wave or a cosine wave? What do you all think? Is that sine or cosine? How do you know it's cosine? Starts at the top, crest to crest. By the way, it could also start at the bottom if it were like down here. It could go like bottom to bottom, like trough to trough would also be cosine. It's just sine goes midline to midline. I guess that's the best way to think of those. This also, here, let me jot that down, that this is, in fact, a cosine. But then we also get the period of this wave. What's the period? Period, not frequency. What's the period? What's one wavelength? 6 pi. So P equals 6 pi. I have to use that to calculate the frequency, which is 2 pi divided by whatever the period is. You always start with 2 pi and you divide by that wavelength. Well, 2 pi over 6 pi, the pi's cancel out. Anything divided by itself is just 1. 2 over 6 simplifies to 1 over 3. So the frequency would be 1/3. If I put this all together, I'm first going to write it with all the numbers in there, then I'm going to kind of clean it up. Amplitude of 1, it's a cosine wave. The frequency is 1/3. What else has to go in the parentheses here, everybody? X. You've got to have the variable in there. That's what's making this a function of x. And then finally, midline of -2. So that's everything put in the correct spots. If I were to just write this nice and smooth, I'd write f of x equals cosine of x over 3 minus 2. So I don't need the 1 in front of the cosine. And then 1/3 of x is the same thing as just x over 3 minus 2. So that would be the preferred way to write it. But again, once above it, I would not mark that incorrect. It's just that's cleaned up a little bit. All right. Thumbs up, thumbs down, thumb side. We okay with this? That's great. Heads up, 7 up. No, I have a better idea. Let's play. Yeah, we're going to play that one game from the half day. Grab out your Chromebooks, everybody. We're going to Desmo's classroom. Dun, 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 dun.